Hello everyone, today I'll be presenting my chemistry project. The title is Rust Observation and Prevention. So what is rusting or corrosion? Corrosion is a chemical reaction between iron, water, and oxygen to form hydrated iron oxide, or what we usually know as rust. Rusting usually happens only on the surface of a metal and is not reversible. This is the formula of rusting process. Iron reacts with oxygen and water and gives off hydrated iron oxide. Corrosion happens because a redox reaction took place. Here, iron undergoes oxidation and oxygen undergoes reduction. These are the nails I used for my experiment. I used 6 different solutions for my experiment. First, an open cup filled with rice. Second, closed cup filled with oil. Third cup is the closed cup filled with salt solution. Fourth is the open cup filled with water. Fifth is the closed cup filled with water. And sixth is the closed cup filled with water and masako seasoning. This is my hypothesis. The nail in cup 3 and cup 4 will rust. In cup 3 because the salt solution is acidic and the presence of sodium chloride will catalyze the rusting process. Cup 4 because the iron is placed in a open cup, right? So I thought it is exposed to oxygen and water, then it will rust. I thought about nail in cup 6 because cup 6 has the masako seasoning solution, right? Masako seasoning acts as a MSG or monosodium glutamate, which are acidic salts. So I started the experiment on November 15 at 6:50 p.m. After 24 hours, the nail in cup 6 starts to have bubbles around it. It's starting to be oxidized. After 36 hours, nothing much changed. Still the 6 and the nail in cup 3 also started to have bubbles around it, but just very little. Then after 48 hours, it's just still the nail 6 and nail 3. There are no changes in other cups. After 60 hours, the nail in cup 6 has already rusted. Then after 48 hours, the nail in cup 3 rusted fully. Lastly, 144 hours. There were no more changes on the nail, but there were like some things lying here. In cup 3, there was like this white things, while in cup 6, there is this brown substance floating. So the result of my experiment is nail 3 and nail 6 rusted. This is because both solutions were acidic. And then there was a change of mass of 1 gram in nail 6. This is valid because when rust forms, the iron's object mass will increase as oxygen has combined with some of the iron. But that's it for the mass change. Then here are the ways I found to prevent rust. I found in general that there are 2 ways, which is barrier methods and sacrificial methods. Barrier methods are when you prevent oxygen and water from touching the iron by coating it with paint, applying it oil or grease, or electroplating. Sacrificial method is adding a more reactive metal to the iron. So when the object is exposed to oxygen, the more reactive metal, which is the coating, will be oxidized instead of the iron itself. An example that uses both the barrier method and the sacrificial method is called galvanizing. This method coats the object in a layer of zinc, which is effectively the barrier method, as it forms a protective coating over the iron. When the zinc coating gets scratched or damaged and iron gets exposed, the zinc will still be the one who reacts with the oxygen instead of the iron, and that is sacrificial method. This is my conclusion and reflection. My conclusion is, in order for iron to rust, oxygen and water must be present. My nails rusted in the salt solution and Masako solution. Both solutions were acidic, so I can conclude that rusting of nails in an acidic environment is faster because they increase the concentration of hydrogen ions. And I also get that rusting can be prevented by barrier and sacrificial methods. For my reflection, my experiment wasn't that accurate. The nail material might not be pure iron. Then my weighing scale is not that sensitive. And there are others maybe. Next time, I must use a weight scale that measures to 1 decimal place and maybe put the nail in a standing position, because this time it was soaked, like really sink to the liquid. That's all. Thank you.